Hello everyone, today in this video we'll be discussing the whole AIML in one shot. That means I'll be just discussing what are the key points in each of the questions which are most expected from exam point of view. So let's get started without wasting any more time, and make sure to hit the like button, subscribe to my channel for more videos like this, and let's get started. So our first question is, what are the task domains of AI? Whenever you hear the word task domains of AI, you have to think about the applications of AI. Applications of AI is mainly categorized into three categories. The first one is the basic tasks. Second is the task which involve gaming and mathematics. The third involves some corporate operation things like the finances and the scientific analysis and the banking stuffs. Okay, so what you have to just keep in mind is, in mundane tasks, that is also known as basic tasks, the vision, speech, natural language translation, and generation, all these things will come in the mundane tasks. The second is the formal task. Here you have games, different kind of games which are built on AI, and then you have the mathematical formulas. And last one is the expert task, that only you have to remember, like the corporate things, financial, medical, scientific, and engineering. Moving on, we have what is AI technique. AI technique means what technique does AI apply. AI applies a technique which is very easy to understand, and it is largely applicable, and it reduces a solution to a smaller number of pieces. So that after that, we will be having three important search things also. It captures general knowledge, it is easily understood by the people and modifiable, it has general uses, and it find out the optimal solution. Then we have the three important AI techniques you have to mention: search, use of knowledge, and abstraction. Moving on, we have tic-tac-toe problem. Here you have to first write the definition, and then you have to write how the player wins. You have to draw the diagram as well. These all things you already know how it works and all. What is the simple approach? That means it uses 0 and 1 to for x, means empty x and o. And for approach 2, you'll be using the magic square formula, and for approach 3, you'll be using the vector method, wherein you'll be using the AI methods to find out the optimal answer. And advantage, disadvantage, for all the questions you have to write just simple things. It reduces the cost, and it takes lesser time for computation, and uses less resources, and so on. So these are the things. And for the disadvantage, just write the opposite of it. Moving on, we have the state space search. That means in a space of different possibilities, you are searching a particular state. What is its definition? It is used for problem solving, that is searching for a goal, and the methodology includes three steps: initial state, process, and final state. We have the examples such as BFS and DFS, wherein we will be using the state space search. We are searching a state which is optimal one, right? Next, we have the production system. Production system mainly consists of four things: monotonic, non-monotonic, commutative, and partially commutative. It is independent, this is not independent, this order does not matter, here order matters. These kind of characteristics are used to solve different kinds of problems. That is what is called production system. Next, we have the requirements of good control strategy. Here you have to remember an alcoholic person. Here the alcoholic person is drunk, so he is not able to move forward or backward also. Okay, so it causes some motion. It should cause a motion. That is a good control strategy. The drunk person does not cause a motion, he will be standing there itself and trying to reach his goal. Next, we have, it should be systematic and give example. Systematic means, if the alcoholic person takes one step forward, he should not take the same step backward as well. He should move forward only. Systematic means moving forward and again coming backward. The examples for the good control strategy, you can give it in the general ways, like you can use the back propagation algorithm also. You have to continuously move forward. You should not again come back to the same errors by redoing the steps what you had done. Okay, so those are the requirements of good control strategy. Moving on, we have the water jug problem. Here the three steps you have to answer this question. The first is describe the states. What is the initial state, what is the final state, and what are the production rules you are going to use. So to remember it in a very simple way: full, half empty, some, full, final. And this is exchange. Full means initially the jugs will be empty, you are filling it to full water. Half means you are just filling it to some amount of water, just few amount of water you are pouring it out. Empty means you are emptying the whole jug. Some means, exchange means, you are exchanging some water from this jug to this jug. That rules. Full means you are putting whatever water is left here full into this until this becomes full. Final means, if this has 2 and this has 0, the final answer is to get 2 in this jug, you will be just putting 2 here. Or if 2 is here only, you will be keeping it as such. Solution, you have to identify. Initially, you will be having empty jugs. First which will be filling, then what will be doing, and so on. All those things consist of water jug problem. Okay. Moving on, we have heuristic search techniques. Heuristic means what? Smart. Smart means it has an efficient search algorithm. Also, it uses the heuristic functions, which uses the optimal values to find out the answer, and it has the knowledge of the context. These are the key points. Okay. Examples include hill climbing, A star, and Neo star. Many people confuse BFS and DFS, but it's not heuristic. Keep in mind. Next, we have what is BFS and DFS. um, breadth first search and depth first search. In breadth first search, we'll be searching using a see, if this is a tree, you'll be searching it like this. Okay, all the neighboring you'll be visiting first. It uses a queue which is based on the principle of first in first out, whereas depth first search is based on the principle of last in first out. It uses the stack. Okay, means you will be going into the depth first, then you will come back again. You go into the depth, come back like that. Okay, write the algorithm. The algorithm includes just visiting neighboring nodes first by taking a list, and here you also will be doing the same thing. And the diagram, you can draw any graph and explain that words. Okay, what is hill climbing? Hill climbing means you'll be using an algorithm to climb the hill and find out the maximum peak. What are the key points you need to write? First, write what's the definition. It's a part of heuristic function, and three types of they need to know the three types of hill climbing and what is the problem and the solution. The problem is you have to find out the maximum peak, but in the solution, what you'll be having is you'll be sometimes getting the least peak. Sometimes you'll be getting a flat surface. In that case, is what you have to do. Those are the most important things. And what is the diagram for it? You just have to draw one diagram. I have mentioned in the theory video and the notes. You can watch that. Moving on, we have A star and EO star. Here it can be asked about the numericals or the theory as well as the diagram. In the definition, you have to write these are the functions which we are using to find out the optimal path. And A star is a function which uses the heuristic values. EO star can be consisting of two or more nodes together. Okay, that is what is called EO star. And what is algorithm for it? Algorithm is you will be choosing the minimum path each time, and you will be going on till you reach the final state. Numerical also I have discussed. You have to find out the least path from each of these nodes and keep on going. You have to maintain a set like that until you reach the final state with the optimal code. After you reach the after you have reached the goal state, you have to again check back all the possible options which can be more lesser. Okay, that's what you have to do in the A star and O star. What is simulated annealing? That means melting of the ice. Okay, how fast the ice will melt. For that you have to remember one definition and formula. It's a variation of hill climbing. Whatever is in the hill climbing, that same thing you have to write here as well. Just the formula you have to remember: P is equal to e power minus dE by kt. P is the physical substance, K is the Boltzmann's constant, D is change in energy, and T is the temperature. Moving on, we have the forward versus backward reasoning. Forward means moving from the start state to goal state, example chess. Backward means from goal state to the start state, which is example is eight puzzle problem. What are the approaches and issues to knowledge representation? Approaches, you have tried the four properties: representational, inferential adequacy, inferential efficiency, acquisitional efficiency. The name itself are sufficient, you can write in your own words. Schemes are for relational, inheritable, inferential, declarative, and procedural. What are the differences between them? You can watch the theory video I have explained in depth. So moving on to the issues, we have the important attributes. What are the important attributes in the AI which we need to consider about that? Which relationship is most specific? Choosing granularity, whether the higher level or lower level. Set of objects which are most relevant, will be choosing that. Finding the right structure to represent the knowledge. Okay, these are the issues you have to keep in mind for the knowledge representation. Moving on, we have predicate logic and resolution. Predicate logic, these are the symbols you need to keep in mind. They can ask you a direct question like this, and you have to convert them into clauses. That itself can be of 8 marks. Okay, and this is for all there exist, implies, not, or, and. Here the three type of conversions you have to do. If the sentence is a pretty straightforward one, like Marcus was a man, you have to write man, then inside that Marcus. Second type of question, all will be coming, all or everyone, like that the things will be coming or people will be coming. They have to use the thing for all. Okay, and Pompeian and Roman. What is given in this order? Pompeian and Roman, right? Just like Pompeian, arrow, Roman. Then we have the another one in which the or can come, so you have to consider two things and the or as well. The third type of thing is in this way. Here you'll be having and, or you'll be having the two types of things, like everyone came here and someone came here. So everyone and someone will take two different variables and mention it like this: loyal to x comma y. Okay. Next, we have the logic programming. The key point in logic programming is that you'll be using the logical assertions to make some decisions. The language uses prologue, and here you'll be using the horn clauses, in which at most one can be positive. One clause can be positive means whatever the clause is given, at least at most one can be positive. More than one literal is positive, that is not a horn clause. Moving on, we have find algorithm, very simple algorithm. The numerical, you can watch the video I have uploaded specifically for this one. Find algorithm, you'll be initializing to a more specific hypothesis. For each example, you'll be considering each attribute of it. If it is satisfied, you'll keep it as such. If it's not, you'll put it as question mark, and then you'll be outputting the hypothesis. Moving on, candidate elimination, you can watch the video for the candidate elimination numerical. For the algorithm, what you have to keep in mind is, if for each training example, you'll consider two things. G is the most general hypothesis and S is the most specific hypothesis. In general hypothesis, for each example, what you have to do is remove from G, remove from S, and then add to S all the minimal generalizations, and then if it is consistent, keep it, else remove it. Okay, like that you have to do the same thing here also, but in opposite way, right? 3 times in practice, that should be sufficient for you. Moving on, we have the ID3 algorithm. ID3 algorithm is the decision tree algorithm. Here what we are supposed to do is, see, we'll be classifying the things. Okay, we'll be given it a table and we have to classify the things. The first step what you have to write is create a root node for the tree. Then you have to check if all examples are positive, label as positive. If all are negative, return as negative. If it is empty, return as default value. Okay, then you have to begin and choose the best classifier attribute, and from that attribute assign it to the root. And when you have assigned the best attribute to the root, in the subset you will consider each value of it. Okay, you'll consider each value of it, and then after that you will be calling it subset. Subset means examples will be passed of vi, means for that particular value what are the subsets possible, that value will be passing, again calling this algorithm, so that the child nodes also branch will be made. Okay, that is what ID3 algorithm is. Make sure you know this numerical as well. Watch the theory, watch the video in which I have solved the numerical of decision tree. Very important question from exam point of view. Moving on, we have issues in decision tree. You have to remember AIA double H. What you'll remember? AIA double H. A means avoiding overfitting data. The data which overfits, you have to avoid that. Incorporating continuous value attribute. How do you incorporate continuous value attribute? By putting them in a range. What are the alternative measures for selecting attributes? You have a measure for selecting attribute which is information gain. Except that, what is the other method that you'll be discussing here? And handling the training attribute with missing examples and handling with different costs. Different cost or missing examples, in that case what you have to do. Okay, that's what is discussed here. And moving on, we have the perceptron training algorithm and or representation. Perceptron, you have to draw this diagram first. You'll be having two inputs and you'll be having weights, and this is the output here. For the representation of the and basically what is perceptron? Perceptron means the single unit. Okay, like the simplest unit of a neural network representation. And for the training algorithm, I'll be discussing. And what is and or? And or means you have to draw and table here, and in that table what you have to do is you have to insert each values, like a is equal to 0, b is equal to 0, multiply them by corresponding weights and find out the answer. If it is less than 1, the answer is 0, and you will be checking with the things present here. If it is same, means it is same. Okay, if it is not, mean you have to apply another formula, which is the delta w is equal to wi minus plus delta wi. For more information, watch the theory, we have made that. Okay, for training examples, you just have to update the weights, that's all. And what is the delta w value? N into t minus o xi. What is n? N is the learning rate. T minus o is target minus output. What's the target? These are the targets, and these is the outputs. And what is xi? Xi is the inputs, which is a and b. For example, this is input, this is input. Okay, moving on, we have the gradient descent rule. Here we have the following derivation, very important from exam point of view. Here what you have to write is delta EW is equal to delta E by delta W naught, W1, Wn. Consider just one of it, like delta E by delta W. After you have done that, write this formula. Okay, substitute this formula here, same, and then you will differentiate it. When you differentiate it, this half will go, and you'll be remaining with this one here. Again, you will differentiate with respect to Wi, and you will be remaining with minus xd here, and this whole thing you'll be substituting back in this formula, and you'll be getting the Wi formula, which is delta Wi is equal to n into summation of td minus od xd. Td minus od xd. Done. Moving on to the gradient descent algorithm, here just one thing you have to keep in mind: update the weights. Okay, just all things you have to set the weight as 0, update the weights, again do the same thing. That's all. Moving on to the backpropagation derivation. In the backpropagation derivation, there are two cases you have to consider. First is the training rule for output weights. Second is the training rule for hidden weights. Let's have a look at each of these. The first one you will be writing is ed by wj. Two things are there: ed by net j by wj. Net j by wj will become xj here, and ed by net j will become ed by oj into oj by net j. Now we have to solve for this and solve for this as well. Solving for this, the expansion is given here. Just the last word you have to remember: tj minus oj. Okay, this one last word, tj minus oj. The middle part, don't worry about it. Write something else here, and make sure write the end thing very well. Okay, that's the trick. Then you have oj minus net j. This one is oj into 1 minus oj. So the whole thing, the formula becomes tj minus oj into 1 minus oj. This thing you have to substitute back in this formula, delta wj, n into this one. So this one will be substituted by this one. So that's what you will be writing here. Moving on, in the same way, we have the hidden unit weight also. It's very simple here. Right, ed by net k by net j. Ed by net k will become delta k. Then net k by net j will become net k by oj into oj by net j. Net k by oj will become wkj. and oj by net j will become oj minus oj into 1 minus oj. Just these three values have to substitute in this formula and you'll be getting your answer. Like they just have simplified it here. Okay, right ones you'll get to know. Moving on, we have the backpropagation algorithm. So basically, what here they have mentioned is five things they have taken. Training example, n in, n out, and n hidden. Five things are there. What are these things you have to mention here? It's just the hidden value, hidden unit values and learning rate values. And here we have the propagation algorithm. Means the four steps you will be doing. First is input. Second and third is calculate the error in output and hidden. That the formulas are given here. Last is just update the weight. Okay, very simple. 8 marks. Then we have the Bayes theorem. In Bayes theorem, you'll have to write the theory. What is Bayes theorem? It calculates the probability based on prior probability and the observable data. Okay, that's all. What is Bayes theorem? And then you have to write this formula: P of H given D has occurred is equal to P of D given H has occurred into P of H by P of D. Okay, these are the expansions of it. You can go through it. Moving on, we have the maximum posteriority, maximum likelihood, and MDL. Let's have a look. What are the key points you have to write for map learning algorithm? Write the Bayes theorem formula here. Just remove the denominator. You'll be remaining with this one. An expansion of this one is this one: 1 by VSHD, which is the version space. If it is consistent, if it is not consistent, it is 0. Next one, maximum likelihood, we have argmax of P of D given H has occurred. HML is equal to argmin of DI minus HXI. D minus H whole square. That's all. D minus H whole square. MDL is what? D minus H whole square. Done. Next, we have minimum description length principle. Here you have to remember two things: LC1, LC2. Okay, that's all. This is the least encoding methods, and H is taken from here. D by H is taken from here. Just substitute that. Done. Moving on, we have the naive-based theory and the numerical. For numerical, what the video I've made and that I've explained the previous year questions answer. And naive-based theory, what you've tried is it's a classifier which based on the it calculates the probability based on the attribute values. Okay, that is what is called naive-based theorem. And for this, you have to remember VAV. What you'll remember? VAV. V means P of V, and geometric mean P of A by P of V. That's all. What is the target function we are getting for naive-based? Moving on, we have the Bayesian belief network. Here I have to remember this diagram. In Bayesian belief network, there will be multiple layers, and this is called as directed acyclic graph. This is called as computational probability table, and here everything is dependent upon each other. That kind of calculation we'll be noting down here and taking the probabilities and calculating. That is called Bayesian belief network. Okay. Moving on, we have Bayes optimal classifier and Gibbs algorithm. Very simple. What you have to write is it makes the most optimal decision or the prediction. Gibbs algorithm works for larger data set. That's all. What's the difference? And for more information, watch the theory video. I've made that in more depth. And the two-step algorithm is this one: choose one hypothesis and classify the new instance by using the E of error in Gibbs is less than or equal to 2 times error of Bayes optimal. Just use this formula. Whichever satisfies this formula, that is a consistent hypothesis. Moving on, we have the k-means and EM algorithm. It both asked for the 10 marks in the previous year papers. What is k-means? It's an unsupervised clustering algorithm, and the algorithm is consisting of two steps. Choose the k number of clusters. After that, assign each point to the nearest cluster. This point will be assigned to nearest cluster, and after all the points are assigned to their nearest clusters, find out the centroid. Again, by using that centroid, find out the nearest points, and when the clusters do not change, that means the algorithm is over. EM algorithm, two-step process: find the expected value, take a hypothesis, update that value by finding out the hidden value, and again keep on doing until you find out a consistent hypothesis value by using maximum likelihood. Okay, that's all. Two-step process. Two formulas are there. You can refer the notes for more information. Next, we have the KNN, which is having the algorithm as well as numerical. Numerical, you can watch the video. I've uploaded it separately for that. And what is algorithm for it? A very simple algorithm. Two steps you have to write here: discrete valued function and real valued function. In discrete valued function, we'll be having the training examples and the classification algorithm. Two parts: training, classification. Here also everything is same, just that this formula is getting deferred. Here you have to write summation of input and output. Okay, v and f of xi. V and f of xi is input and output, and here if both are same, the output will be 1. If both are different, the output will be 0. And here it's just calculated the mean. Okay, means summation of f of xi divided by k. The whole mean is getting calculated. And what is in training example? Take each training example in the form of input and output, which is x comma f of x. After that, classify a new instance by considering all the possible instances by using this formula. Same thing here also by using this formula. Done. Moving on, we have the locally weighted regression. Here it means you'll be having some local points. You'll be having each will be having some weight. You'll be calculating the regression value of it. Okay, so you'll be considering f of x equal to w0 plus w1 x1 plus till wn an xn. When you will be writing this formula, you have to also calculate the errors in between. So you'll be using this formula for calculating errors. And how you'll update using this formula. Delta W is equal to learning rate into summation of f of x minus f of x, f dash of x into ag of x. Ag is the attribute value, f of x is what value we have got, f dash of x is the value which we are expecting. Then moving on, we have the radial basis function. Radial basis means circular. Radial means circular. Two formulas you have to remember. First, right, what is the meaning of radial basis? It is related to distance weight and artificial neural network. After that, write this formula. Remember kudu. Okay, W naught plus WU KU DU XU. Okay, kudu. And what is KU? KU DU XU is e power 1 by 2 sigma square into D minus U whole square. D of XU comma X whole square. Okay, this is what about the radial basis function. Moving on to the case based reasoning, which is cadet. Here we'll be having an existing case and we'll be finding out a new case. That's all. What is the case based reasoning? Here we have a temperature and the quantity of water 1, which is hot. Here we have a quantity and temperature 2 of water 2, which is cold. Mix it and you'll get a water which is the normal one. Just that you have to explain by using the different separations, like for the quantity differently and the temperature differently, and you will be expecting maximum marks for that. Okay, just that you have to consider an example I explain. Okay, moving on, we have the reinforcement learning. Here you have to remember what is reinforcement learning. Few key points. There is a robot like this robot, and he will be learning the environment. He'll be in an environment and he'll be learning many stuffs. He'll be in state 1, put an action, go to state 2, put an action, go to state 3. At each point he'll be getting an reward. Okay, and his task is to reach the goal state with maximum reward. Okay, that's all. What is the reinforcement learning? And this is the diagram for it. Agent will be there, environment is there, state and reward is going to the agent, and agent is performing an action. S naught, A naught and R naught is the initial cost, initial state, action, and the reward, and like that we'll be keep on going until we reach the goal state. Moving on, we have the learning task and Q learning. In learning task, we will be learning something with by using the Markov's decision process. Here we'll be finding out the optimal policies, optimal paths, what's the optimal reward, from which state what action is to be taken. These 5 key points I have mentioned. And then we have the Q learning. This implements the learning task. Q learning is the thing which implements the learning task. Okay, so this is the formula. Q of S comma A. You have to remember this formula. S is state, A is action, and R is reward. S comma A means in which state you are performing which action, and this is the delta value, and V star is the value based function, and delta S comma A, what is the value you are getting from that reward, and that you are multiplying by a discount factor, because as far as we go that much should be discounted, and that will be added to the previous reward, that will be updated back into the table. Now we have in the table many values which are differing costs. We'll choose the best one, which is the least one. That's why we will use this one, which is the optimal policy. Here we will choose the maximum reward. Okay, not the least one, the most one. Maximum reward which we are getting, that one will be choosing, and that is what is called Q learning. And the algorithm is as follows. You'll be in a state S comma A, initialize the table entry as 0 initially, choose a state, perform an action, get the reward, observe the new state, update the previous entry, and move on further with the new state. Okay, that marks the end of this video. Make sure you hit the like button, subscribe to my channel for more videos like this. Thank you so much for watching. I'll see you in the next one.